residue in this thing has exactly 2 square roots. So first of all, we're going to talk about Z mod p. So this is just something, basically the ring of integers modulo p. This is all the numbers from 0 to p minus 1. So just like we saw before. Then this thing with the Z mod p star is the group of units in the ring Z mod p. And something is a unit if it has an inverse. And so if you're not taking abstract algebra, this might sound a little bit weird, but basically you can picture it as, so Z mod p is just all the numbers from 0 up to p minus 1, where p is a prime. And Z mod p star is the same numbers, except we don't include 0, because we don't have an inverse for 0. Okay, let's go ahead and see how there's only exactly 2 square roots. So yeah, first of all, we're going to let y and Z mod p star be a quadratic residue. That means, basically by definition, that there exists an x that's also in Z mod p star, such that x squared is congruent to y mod p. Okay, so then we have x squared is congruent to negative x squared, which is congruent to y mod p. So we're just going to claim that x is not equal to negative x mod p. In order to prove that, we're just going to suppose that it is. So suppose they are actually the same number, in fact. Then that would mean that x plus x is equal to x minus x, which implies that 2x is equal to 0 mod p. That would mean that basically what you can do from that is write that p divides 2 times x, since that means the remainder when you divide 2x by p is equal to 0. And hello.
Hey, come in. So you're supposed to McDonald's there.
Huh?
McDonald's there.
What?
McDonald's there.
Yeah, you can get some food.
Oh, okay.
Okay. Alright. And since p is greater than 2 and p is greater than x, so p divides neither 2 nor x, so it's impossible for p to divide 2x. We have a contradiction. Which means that x is not equal to negative x, and both x squared and negative x squared are congruent to y mod p. So we have found our 2 square roots. Yeah. So basically what that means, oh wait, we also have to show that there's no more than these 2 square roots. So since x and negative x are distinct, y has at least 2 square roots. Okay, suppose that there was another square root out there. So we say that x squared is equal to x prime squared is equal to y, where x prime is also in this z mod p squared, so all the numbers from 1 to p minus 1 is another square root of y. Then that would mean that x squared minus x prime squared is